Unless you've been living under a rock or something, chances you've heard about AI agents revolutionizing the AI industry and how tech giants and other Fortune 500 companies are planning to introduce some type of agentic workflow both internally and for their clients.
I think the progress that you're going to have with agents over the next year or two is going to be spectacular and surprising.
But just like any new industrial paradigm, the agentic framework also suffers from many problems in these early stages. Hallucinations and inaccurate responses, issues in connecting with external sources of data and tools, and coordinating between different language models in a system are just some of these problems. So I'll be talking about some of the super interesting and new research and project initiatives in AI agents that claim to solve these problems, including Google RIG technique, OpenAI Swarm system, and Adala. RIG is one of these systems that have been introduced recently to overcome some of the RAG's challenges. As a quick overview, RAG or Retrieval Augmented Generation workflows employ multiple large language models in a series of specialized tasks, usually by retrieving relevant information from external sources of data, such as a PDF, spreadsheet data, or web links. But if, like me, you have worked with enough RAG setups, you have faced LLM hallucinations a lot. But recently, Google introduced its latest model, DataGemma, which, unlike previous RAG systems, works on a RIG or Retrieval Interleaved Generation technique, which merges language models with data commons, which is an open-source, large-scale database of public data. This means each time a user has an inquiry which the LLM doesn't have prior knowledge of, the RIG side of the RAG system retrieves the correct response from this large database instead of making up non-existing data with confidence, as we all have seen before. This system is fairly new, so we don't have enough information on its accuracy of responses compared to previous RAG systems. But I can tell from this strategy that, at least for current events or specific up-to-date information and statistics that haven't been used as part of the training data for the LLMs, integrating RIG to access new relevant content can be a massive game changer for any industry-level agentic product. Unlike RAG, which performs a single retrieval before generating the answer, RIG can adapt in real time while creating responses, refining its output iteratively as it retrieves new information. In other words, RIG facilitates multiple data retrieval throughout the response generation process. This flexible method enables AI to recognize knowledge gaps and fetch data from external sources several times during the conversation. By continuously gathering and incorporating data, RIG minimizes potential inaccuracies in the final output, particularly for complex or specialized queries. However, compared to previous RAG systems, RIG may experience slight performance delays due to pauses at various points to retrieve the latest information. As you can already see, this method helps RIG systems to minimize hallucinations. Now, the evaluation of the RIG approach demonstrated improved factual accuracy with their 27 billion parameter fine-tuned model. Here, data commons plays an important role in the RIG system, as it serves as an extensive data graph containing over 240 billion data points across many statistical variables. Any other rich repository of information for other RIG systems can do the same to generate accurate responses. Honestly, I have tried a bunch of methods and prompt engineering for dealing with LLM hallucinations, including my long prompt to CrewAI in this video. So I'm looking forward to testing the RIG technique and comparing it with my previous prompts. But if you have a secret prompt that has worked for you to avoid LLM hallucination, I really want to know. But hallucination is not the only challenge we face when using AI agents. What really distinguishes a great agentic system from a mediocre one is superior agentic coordination and execution. In other words, how various LLMs in the setting communicate with each other, make decisions among themselves, and use those decisions to complete a task. It seems easy, but when it comes to implementation, agentic systems often lag behind this coordination effort. Multiple research solutions have already been suggested, but OpenAI's Swarm system may become more successful because of its huge funding. So basically, according to OpenAI, Swarm focuses on making agent coordination and execution lightweight, highly controllable, and easily testable. Swarm uses two subsystems of agents or routines and hands-offs, where an agent is responsible for instructions and tools and at any point during the process can hand off the responsibility to another agent. They refer to routines as a set of steps, for example, a list of instructions in natural language, similar to the concept of prompt engineering, but equipped with necessary tools to carry out the tasks. Here's an example of a customer service routine that they have published in their cookbook, where the agent tries to figure out the customer's problem and then tries to either fix it or issue a refund. They show how good LLMs are in following steps and use these to build customized routines, but with the advantage of letting the language model handle the dead-end conversations by getting out of it. They also showed an implementation of this system for weather agents, personal shoppers, and airline customer service. Even though they have mentioned that the Swarm system is not production ready yet, you can already see the potential of such systems for more scalable and real-life applications. If you've been hanging around my channel, you might remember the IOA system or Internet of Agents system that I explained in detail in this video, which to be honest has a more thoughtful design than Swarm. But I think Swarm, having the backing of a giant tech company such as OpenAI, can get to the fully fledged production phase a lot sooner. You can already tell by the number of stars and forks the GitHub repo has received. That said, if you'd like me to run the Swarm system for you, please do let me know in the comments. If you've already done so, I'm curious to know how your experience has been. There are so many new advances in AI agents that I will share with you in future videos, not to make these videos super long. But one more agentic system that I wanted to explain is this super cool Adala system, which was introduced several months ago, but honestly, it's so underrated. So Adala stands for Autonomous Data Labeling Agent Framework. In their GitHub repository, they described it as Adala offers a robust framework for implementing agents specialized in data processing with an emphasis on diverse data labeling tasks. These agents are autonomous, meaning they can independently acquire one or more skills through iterative learning. This learning process is influenced by their operating environment, observations, and reflections. Users define the environment by providing a ground truth dataset. Every agent learns and applies its skills in what we refer to as a runtime, synonymous with LLM. In other words, Adala is a unified data labeling system that is entirely handled by LLMs. Given the ground truth or a set of human-verified data labels which is given to the system as the training data, the system runs agents for a specific skill, for example, sentiment analysis, question answering, and text classification, while giving the agents a defined role and how to process the data. The user can also choose a specific LLM, even the models which require API keys for access. The agentic flow then starts learning from the training data and applies its understanding to your chosen set of final data or test data. Sounds like what we've been doing with supervised machine learning on our own, but it's so cool that we can reach such a high labeling accuracy with LLMs that we can effectively trust them to do the entire process on their own. I believe one thing that they can add to this system is a chat-like interface where new instances can be given on the fly to make the experience a bit more informal. If you're interested to know how this labeling system works in a more hands-on tutorial, definitely let me know in the comments. And here's the video about the most influential AI agentic research and systems.